Right, as part of today's lesson, I want a nice diagram in your books. And to draw this diagram well, part of it has an ellipse. And then we have looked at drawing ellipses before, but it's a good time to have a look at this again. So I'm going to use the pin and the string method. And I've got two drawing pins or pinboard pins, and I've tied a piece of cotton between them. You can see there. And I've got my paper resting on, I found an offcut of timber in the garage, or if you've got some soft cork board or something like that you could put below it, that helps, because you're actually going to push these pins into the paper. Now if I bring the pins and put them in close to each other, right on top of each other, that will produce a circle, but the further I spread them, the more stretched out the ellipse would be. And actually I want a fairly wide ellipse for this diagram, so I'm going to pop my pins in, say about here and here. Just push them into the board there, and now all I need to do is just take my pencil and rest the pencil in that string there and just start drawing. Don't have to rush, and you should find you produce a nice smooth ellipse. Now I can't go any further there, so I'm going to have to come back and go back the other way. Just trace back over where I went, come back down to this side, pop my pencil out because I need to go the other side of the string now. Get my pencil hooked into the string there and do the same around here, and we meet up nicely. Yeah, that's good. And back here, and we meet up nicely. So that's my ellipse drawn, and that's the first part of the diagram that we need to produce in our books today. So you might want to do a pin and string method for drawing your ellipse. Okay, so this diagram that I need to go into your book, we're going to have this ellipse at the bottom here representing the ground. And what you need now is a compass. Now I'm doing mine A4. You're probably going to do yours in the sort of the width of a page in your book, which means I'm using sort of an extra long compass here. I've found the center of that ellipse, and I'm going to stretch out my compass to the edge there. You see I've stretched it to meet the edge there, and I'm just going to go with my compass up and over the top, and this is representing the sky above there. So I've done an arc that goes up over there. I think we're going to go over that with a blue pen. So I'll carefully trace over that with my blue Sharpie, and that represents the sky going over the top there. Okay. So I've added to my drawing the labels north, east, south and west, and if we had a person stood in the center there, let's put a person in the center there. That's if they were facing north, to the east of them, the south of them and the west of them. North, east, south, west. So if they were facing towards the North Celestial Pole, they'd be looking up sort of towards this way into the sky. Okay, so we've said that on the equinox, on the days of the equinox, the path of the sun, well, it rises in the east and it sets in the west. So it's going to go up to the top here and come back down, rise in the east and sets in the west. During the summer months, we get longer days, and it's going to rise further to the north, east, and set further to the northwest. And in winter, it's going to rise further towards the southeast and set further towards the southwest. And we can trace out 3 paths on this now. So for the equinox to start with, we start here. We're going to all the way up here and come back down here. So I've now drawn on there the three paths. For the equinox, we rise in the east, we take the path up here, the sun takes the path up here and down here. So this is the highest point when it's on the south. For the summer months, we rise further towards the north, we come up and we come back down here. So the sun will be higher in the sky when it reaches its peak in the summer months, and in the winter months we rise further towards the south, we come up and over and down, and we'll be lower in the sky, and we set further towards the south. So we can label up those three stages there. So I'm going to call those the equinox, and we've got the summer, and in fact, if this is the furthest round that it would set to the north or rise to the north, then that would actually be the summer solstice. But that certainly represents a summer situation, and here is going to be winter. And again, if this actually does represent the furthest round, it would rise to the south and set towards the south, then that would also be the winter solstice. But you get the idea. We get this motion from springtime, the sun will reach a peak here, towards summer, we'll see it rise higher in the sky, then come back down towards autumn, we'll see it go back towards that first point in that where we saw it spring, and then towards winter the sun will be lower in the sky as it rises. So this variation in sun path from between spring and autumn to summer and winter not only affects the height of the sun, so spring, very high in summer, and we won't be that high in the sky in winter, but it also affects the time that the sun will be visible and in the sky. So if we look at winter, okay, it's got a very low path, it's not going to be in the sky for that long. In the equinoxes, it rises in the east, due east, it sets due west. In fact, that path there is longer than in winter, and that will take 12 hours, exactly 12 hours on those equinoxes. And then when we get to the summer, when it rises further north, it's got a much longer path that it takes, or appears to take, in the sky during those days, and it's going to have a much longer period of daytime for summer months. So these paths affect the height of the sun at midday, and also affect how long the sun is going to be in the sky, so the daylight hours. Get this diagram into your books, neatly drawn up and neatly labelled, with the summer path, the equinox paths and the winter path. Make sure you get your compass points on, and that needs to go into your books.